In our last video, we talked about what a mole was and how we would use it to convert to the number of atoms or particles or molecules using that Avogadro's number, that's 6.022 times 10 to the 23. So how do we apply that to actual problems? Let's look at this first example here. If we're given 15.4 grams of beryllium, that Be is beryllium, how many moles of that beryllium do we have? So we know we were given 15.4 grams of beryllium, but we don't yet know how many grams are there in a mole. So we are looking for what's called the molar mass. So how many grams or something are in 1 mole? And the way we find that is we look at our periodic table. So notice over here we have beryllium, and we have this 9.012. Again, that is our atomic mass. But something we also know is that 9.012 is the number that we use for our molar mass. So if we want to figure out how many grams are in a mole, we just look at that number, and it is 9.012 grams per mole. So we put this right here, so we cancel out grams, and we're left with moles. When we plug that into our calculator, we get that we have 1.71 moles of beryllium. So using that, now we can take our 1.71 and figure out how many atoms of beryllium do we have. Remember we said that Avogadro's number is how many atoms or molecules or particles of something you have in 1 mole. So in 1.71 mole, it was what we got from the previous question, times that 6.022 times 10 to the 23 per mole. So we get that we have 1.03 times 10 to the 24 atoms of beryllium. So that's why this mole is very important, because this is a huge number, where we can instead just say we have 1.71 moles. We can apply the same logic when we're talking about compounds. So for example, we say we have 13.6 grams of NaCl. So how many moles do we have? So remember, NaCl, that's sodium chloride, that's just your standard table salt. So we were given 13.6 grams, and we need to know how many grams are in 1 mole of NaCl. This one is a little bit different because it is a compound. You have to find the molar mass of both parts. So subscripts are important for this. In this case, we don't have any subscripts. We just assume that it's 1 because there are no subscripts written. But if you had had a subscript, you would have had to count, like for example, if we had 2 chlorine, you would have had to multiply this number by 2. So I just got these numbers from our periodic table. Sodium, we got 22.99, as you can see right here. And then chloride, 35.45. So I added those together. My molar mass for NaCl was that 58.44. So we were given our grams, 13.6 grams times 1 mole, which is 58.44 grams. And we get that we have 0.23 moles of NaCl. So let's look at a couple more practice problems. So let's say that we have 47.2 kilograms of CaCl2. So how many moles of CaCl2 do we have? So the first thing to notice, molar mass that we've done in the last couple problems, it is in grams per mole. It is not in kilograms per mole. So we first have to convert those kilograms that we were given to grams. So the first thing that I would do is get 47.2 kilograms, that's what I was given, times 1 kilogram is 1,000 grams. That is something that we already know based on our conversions, and you can also find it on your reference sheet. So those kilograms cancel out, and now we have grams. We know that we want to get moles by the end of this problem. So we calculate our molar mass, and I did that over here. So calcium was 40.08. Again, we have 2 of chlorine because there's a subscript there. So 2 times that 35.45 is 70.9. Add those all together, and we get 110.98 grams per mole. That is our molar mass. So again, grams is on top here. We put it on the bottom here so it'll cancel out per 1 mole. And we get that we have 425.3 moles. But because we are using significant figures, there were 3 in the example in the question, we get 425 moles of CaCl2. So we can also look at this another way. If we have an equation like this one, and notice here it says the equation must be balanced, we can do a little mole conversion. So this question says, what is the total number of moles of NH3 produced when 10 moles of hydrogen gas reacts completely with N2? So notice we've already balanced it out. We've been given this balanced equation, and we want to find how much NH3 we have if this H2 has a coefficient of 10 in the front. So I've rewritten the problem down here at the bottom. We have N2. It doesn't matter how much N2 because we were told it reacts completely. So we're not worried about the number in front of N2 right now. But we know that we have 10 of that hydrogen gas, and we're wanting to know how many of that NH3, how many molecules basically. So we had 3 in the beginning to get a balanced equation, so we multiplied that by 3.33 in order to get to 10. So we would multiply this coefficient by the same number, and we know the coefficient at the top was 2. So that 3.33 times 2 is at 6.66666, bunch of sixes. So I would just say 6.7 moles of NH3. So again, you're using your significant figures. We had 10, now we have 6.7. So let's look at another example of that. If we have this equation at the top, so sodium is reacting and we're getting Na2S, what is the total number of moles of S, this right here, that reacts when 4 moles of sodium were completely consumed? So again, I rewrote the equation down at the bottom to help me understand that. We're not asking anything about this Na2S right here, so we're not worried. But we know that this is 4 of sodium. Notice when we first balanced that equation, it said 2. So to get from 2 to 4, we had just multiplied it by 2. So do the same thing to the coefficient that was in front of the S. The coefficient that was initially in front of that was just a number 1. So 2 times 1 is 2. So we know 2 moles of S. So remember, all of these equations must be balanced before you do these mole conversion problems.